11. Still dealing with rational equations and expressions, but in this one we are not just simplifying, we are going to multiply and divide them. And then, as always, when you multiply and divide, your answer needs to be simplified out. So without further ado, let's go here. Find each product. So remember, when we multiply fractions, we multiply across. If I were you, to save yourself, usually you can't reduce above and below because it's not going to be reduced form, but you can cross reduce. So I can take a z out here. A 21 and a 7 would be a 1 and a 3, and then the 10 becomes a 5, where the 2 becomes a 1. Then we have x squared here and x cubed, which eliminates that. And there you go. Now multiply across. You have 1 times 1. So your numerator, you just have x, y. And in the denominator, you have 5 times 3, which is 15. And no variables at all. Now, if you multiply first, that you can do that. If you decided to multiply first, it would simply be 2 times 7, which is 14x to the third y z, and on the bottom would be 210 z x squared, and then simplify. Or even 21 times 10, and just simplifying that way. And then you could take out the x's, the z's, and then take out a 7, which would make this 2, and this 30. Take out a 2, which would make that 15, and you have x, y over 15. Either way, I like my way because it saves me some of those big numbers when I multiply first. But I don't care, it's totally up to you. That's when we've got monomials. When we've got binomials and trinomials, we have to factor first because we can only cancel or simplify when it's products. So take a look at this. These two are already in products, but we are going to factor the numerator here in this top one on the first to make it two binomials. So we have a minus 2 and a plus 1 all over. And then I'm just going to add the others because when we multiply fractions, we multiply across, and a plus 1. And now check that out. We can cross reduce, and we are left with a simple a minus 2. And it is that easy. Yeah, right, that easy. As long as you can factor, life becomes easy. Okay, why is this important to understand? Well, in real life, besides algebra, because that's when we deal with these binomials, trinomials, and that, in real life, we use this for dimensional analysis, which just means when I've got different labels that I want to get rid of. So take a look at what this says here. A garden snail was found to have traveled 1.44 miles in 2 days. What is that speed in inches per day? Okay, well, I'm going to start with my first one that they give me, which is 1.44 miles in 2 days. So notice I put over 1.44 miles over 2 days. So I need to change that to how many miles, or sorry, excuse me, inches right here per day. So day is fine. I don't need to change days because that's fine, but I do need to change miles into inches. So in order to do that, I can't really go straight from miles to inches. So I'm going to go from miles to feet and then miles to inches. Now miles is in the top, so in order to get rid of it, I'm going to have to put it in the bottom. And when I do that, I have 5,380 feet per mile. So now my miles cancel, and then I still have to cancel out the feet so that I get inches, and there are 12 inches in 1 foot. So now my feet cancel, and I multiply across. So I'm going to take that 1.44 times 5,280. Ooh, sorry, 280, and times 12. And then on the bottom, 2 times 1 times 1 is 2. So I get a really big number, 91238.1 over 2. And then just divide that out. So my answer is 45,619.2 inches per day. That's crazy. That seems like so unbelievably big. But I guess 1.44 miles in 2 days. I'm just surprised that a snail could go that fast or that far. Fascinating. All right, let's try this again. Anne Proctor won the 2007 World Water Ski Racing Championship in her category when she finished the 88-kilometer course in 51.23 minutes. What was your average speed in miles per hour? And look, they give you a hint because I can't change kilometers to miles without some sort of help there because I don't keep that one in the back of my mind. I'm sorry. Maybe some of you do, but I don't. That's pretty good. So I start with the first one that they give me, which was 88 kilometers per 51.23 minutes. And then I think about what I need to get over here, which is miles per hour. So easy peasy, lemon squeezy. I'm going to change my minutes to hours. So since hours needs to be in the bottom, hours, and I'm getting rid of the minutes up here. So I got 60 minutes per 1 hour. Now my minutes are gone. Okay, and now I need to change kilometers to miles. And in a kilometer, 1 kilometer equals 0.62 miles. So I need to get rid of my kilometers, and it is in the numerator. So I need to put it in the denominator so it cancels, and they're 0.62 miles per kilometer. So now my kilometers cancel. I'm going to take 88 times 60 times 0.62. So in the numerator, I got 3,273.6. In the denominator, I have 51.23 because those two are just ones. And last but not least, divide that out. Divided by 51.23. Oops. So 3273.6 divided by 51.23. And that is still not right. 273.6. divided by 51.23. Finally, to the nearest average speed in miles per hour, it's 63.9. So I'm going to go ahead and make it 64 miles per hour. Okay, let's move on. Turn your paper over. That is dimensional analysis, so that's how we do that. But going back to dividing, multiplying and dividing. Multiplying is easy. Multiply the top by the top, bottom by the bottom. So let's think back. How do we divide fractions? Hopefully in your head you said multiply by the reciprocal right here. So the first one stays the same, but we flip the second one. So I would start by rewriting it over 7 times 7 over b, which means my b's cancel, my 7's cancel, and the answer is 2a. Pretty simple. Same thing with the second one. I leave the first one alone, 4 over 15n cubed, but multiply by the reciprocal, so 25n over 12. I'm going to cross reduce. I can take a 4 out of the 12, which gives me 3. I can take a 5 out of the 15 and the 25, which gives me 3 and 5. And then my n in the numerator, I take one of these out, which leaves me n squared. So now multiply across. I have 5 in the numerator and 3 times 3, which would be 9n squared in the denominator, and that I can't reduce anymore. Okay, well that was simple because those are monomials. What happens if I've got an expression that contains polynomials? Well, we still do the same thing, but now we're going to have to factor. So take a look at this first one. I leave the first one alone in that I don't change it, but I am going to factor a 3 out of the denominator, which would be n minus 4. Now I'm going to flip that second one because multiplying by the reciprocal. And then cross reduce if I can, and I can because I can reduce that. And so my final answer is n plus 6 over 3. All right, same thing on the second one. Okay, in that first one again, I can take a 2 out and I get x plus 2 over x plus 1 and multiply by the reciprocal. So n plus 1 over, x plus 1 over x plus 2. I can cross reduce. Check this out, that one, and that one, and my answer is simply 2. Beautiful. All right, expressions involving polynomials. So those are pretty simple. Now we're getting a little more complicated. Now we've got some trinomials. So we still have to remember to flip the second equation or the second fraction, but we also have to factor everything down. So in that first one, doesn't change the denominator, but the numerator, if I factor it, becomes -3 and -10, k minus 3 and k minus 10, but now I'm multiplying it by k minus 2 over k minus 3. So we can cross-reduce these, and my answer is simply k minus 10 times k minus 2 all over 10. And I know some of you are thinking, oh, can't we reduce that? No, we can't. Now, if you want to multiply that out, you can, but I'm okay with just taking factors there. Just leave it as two binomials. Don't multiply it out and get the wrong answer just simply for math error. All right, leave it alone. Take a look at the second one. And if you factor it, you will get two binomials in the denominator, which is a -8 and a -2. Let's flip this second one. And while I flip it, y minus 8 is in the top, but I'm going to go ahead and factor this one right away, which would be y plus 3, y minus 3, because it is a difference of squares, y squared minus 9. You know, I flip-flopped this one. That's why I get this on the bottom and that one on top. Now cross-reduce. Check this out. Those two cancel, leaving me with just a 1 in the numerator, because that's what happens when I simplify a fraction. It doesn't go to 0, it goes to 1. And then in the denominator, I have two binomials of y minus 2 and y plus 3. And there you have it. There's multiplying and dividing polynomials. That factor. We're going to get into long division of polynomials in a little bit, but your assignment is on a separate sheet of paper, so hopefully you grabbed it. It should be green, but pretty simple. We've got 12 through 20 even, and then 21 through 35 all. There are 20 questions. All right, you should be good. Come see me if you have any questions.